All right, so what was your project about?
So I conducted a project on cancer research. And what I did was I used nanoparticles, which are naturally toxic, certain nanoparticles, and I coated them in folate to target cancer cells because cancer cells are growing at a faster rate than normal cells and require much more folate. So the cancer cells will take in these toxic platinum nanoparticles because they're coated in folate, which essentially tricks the cancer cells. And the cancer cells, since they're taking in so many more of these nanoparticles than the normal cells, will receive a much deadlier dose of platinum.
So what exactly is folate, though?
Okay, folate is a vitamin that all cells need to grow. It helps with cell reproduction, things like that. But since cancer cells are growing at a much higher rate, they need so much more folate.
How did you get the idea for this?
Well, I worked in a lab at Stony Brook 2 summers ago, and I just looked at nanoparticle, general toxicity of certain nanoparticles. That was my project last year. So this summer I came back to the Garcia program, and I wanted to use, I had a goal of somehow working with cancer and keeping up my theme of nanoparticles that I used in the previous summer. After talking to my mentor and reading up on articles, I came up with this idea.
Okay, great, cool. And so who was your mentor?
Dr. Miriam Rafalowicz. She's the head of the Garcia program at Stony Brook. She was, I guess, overall my mentor.
So can you give me like a day-to-day type of experience, routine, whatever you did?
So usually on Fridays and Saturdays on Saturdays and Sundays I go home and I take the train home, so I'm not there. But on Monday through Friday I sleep there. So I get up at about 9 o'clock, and at 10 o'clock I have breakfast, and at 10 o'clock we have a meeting of all the kids in the Garcia program. And they'll either have important lectures for the first few weeks. It's a lot of lectures. And then after that, it's just lectures that really pertain to your research. And then at about 10:30, 11, you break out into your lab. And depending on what you're doing, you could work in your lab for just about 4:30 with a lunch break. And that's usually what I did. I'd finish in the lab at about 3:30 for me. Some kids have their projects take more time. They have tests that take longer, and they could be there until 6:30. But after that, we usually play sports or ultimate frisbee. After that's basically the experience.
Cool. So it seems pretty organized.
Yeah.
And was there any formal training you needed before you began?
Right. Yeah. So for the first 2 weeks, essentially, there's a lot of lectures, and also that we go through lab safety. They give us a tour of the facilities. They essentially teach you how to work in any one of the labs that you might choose. And then when you break down, when you break down into your lab, you've already had the experience of looking into that lab.
So how did you carry out your project? Like methods, materials?
Right. So.
But like general though, So.
Okay. So the first thing I did was I wanted to see how the nanoparticles really affected the cell's growth. So I did some growth curves. Then after that, I wanted to look at how they affect cell health. So I did confocal microscope images. And lastly, I wanted to see, do these nanoparticles really get into the cancer cells more than the normal cells? And to do that, I used the optical microscope. So those were the three main focuses of my research, those three graphs, and then the 2 different microscopes.
So after you did all that, what type of data analysis did you run?
Right. So with the growth curves, it was clear that they were having a more toxic effect on the cancer cells than the normal cells just by about a 60% difference in survival rate. But I did a significance test on that. And then the images, I knew how to analyze them from last year, so I was able to, even though they're images, I was able to somehow say how the nanoparticles were having a different effect on the normal and the cancer cells by judging by the image.
Cool. All right. So, like major conclusions you can make after.
My main conclusion is that you can actually use nanoparticles. You can coat them in folate to specifically target cancer cells and kill cancer cells while having little to no effect on normal cells. And I also proved the principle that you can really coat nanoparticles in any type of ligand to naturally target an overexpression of a receptor on any certain cell.
Cool. All right. And just like another basic question, any things you wish you could have added for the future?
One of the things I wanted to do was I wanted to actually test this on another cancer cell line. Right now, all I did was a bone cancer cell line, which can somewhat serve as a model for other types of cancer. But a lot of times I get a question, how do you know this would work on other types of cancer? And my best thing is this is a model. I just assume it would. But I would like to have worked with another line also to have a definitive answer to that.
So overall thoughts about the whole research program?
I love Dr. Wesley. I really do. The experience has been great. She's helped me so much. I haven't been in the program. I really just started, at the end of last year, this year. But getting all my Intel questions done before the school year started, things like that has been great. I was doing college applications, and I would say to my mom, I wouldn't be able to do the Intel questions if had I not done them over the summer.
Right.
So that's one thing that I'm really grateful for, and just I've had a great experience overall with the research program.
Cool. And advice for future researchers in ninth grade now?
What I would say is, choose a project, something that you actually care about, something that's important to you. A lot of kids work on things, they try to find what they think is the best project, what they think will be the best project, but what really will be the best project is something that matters a lot to you. And then to combine those two things, something you think is going to be a good project and something that's important to you, that should really be your goal. And once you do that, you have a successful project on your